to discuss about high-level synchronization tools. That is, we are exploring semaphores, mutex logs, monitors, and classic synchronization problems. Now we are discuss about the learning objectives in this class. By the end of this section, we will be able to learn the semaphores and their operations, the differences between the counting and binary semaphores, and also how to implement the mutex logs for mutual exclusion, monitors and condition variables, and we solve some classic synchronization problems, and we analyze producer consumer, traders writers, and dynamic philosopher problems. As we see, the key concept is involved is the high level synchronization tools provide abstractions that make easier to write correct concurrent programs while hiding the complexity of low level synchronization mechanisms. The first topic we are going to see is semaphores. Semaphore is a synchronization primitive tool that maintains a counter and provides two atomic operations, that is wait and signal. As it is a synchronization tool, used to control access to a shared resource by the multiple threads of the process. How it works, as it has integer value miscounter, two basic operations involves. One is wait RP, and there was a signal RV. Wait RP means it decreases the counter. Signal RV, it increases the counter. As we see, types of semaphores. The types of semaphores are counting semaphores and binary semaphores. It's also called as mutex. Counting semaphores means value can be any non-negative integer, as it used to control access to multiple resources, as the initial value is equal to number of available resources. The counting semaphore value is always greater than 1, means it allows multiple threads to access multiple instances of a resource. And also the next one is binary semaphores. The value can be either 0 or 1, used for mutual exclusion, similar to the lock mechanism, as it acts like an honor of signal, as similar to the lock. Now we are going to see the advantages and disadvantages of the semaphores. Advantages of the semaphores is that as it can be used to control access to multiple instances of a resource at a time, like using counting semaphores, like integer value. It works for inter-process communication IPC. It allows thread signaling, like one thread wake another. And also the disadvantages of the semaphores is that more complex to program and debug, no ownership, like any thread can signal, or even if do not wait. If they do not wait, they can access. Like these can lead to errors also. If not careful, they can also cause the deadlocks or priority inversion. Now we are going to see the semaphore operations via code. Now we are going to see the semaphore structure. The first one is type def structure. Like here we defining the semaphores, like you define a new data type called semaphore using the struct. And also the next one is int value. This is the counter. It tracks how many units of the resource are available. Like if value is 3, the 3 processes can access the resource. Next one, struct process into list. It is called waiting queue, as a pointer to a list of waiting processors. If the resource is busy, processor added and put to a sleep. Next, we are going to see the wait operation. In that one, we see P operation acquire. Function to here wait semaphore into S. This represents as the function to request access to the resource. Here S is a pointer to the semaphore. If S value is greater than 1, like it decrease the counter by 1. If the resource is available, this process allows the process to enter. Like if the S value is less than 0, the counter goes to negative. It means no resource is available. The process must wait. And next we will see as it block the process. Next we see the signal operation. As is called as V operation. Signal operation in that semaphore into S. As the semaphore is greater than value, the signal in the signal operation, the semaphore increments. We can see that function to release the resource. S is acts as a semaphore. Increase the counter by 1. A resource has been freed, and also if there are still processes waiting in the waiting stage, the values can be negative and it wait to one up. Take one process out of the waiting list. And also here wake up P means here the process is resumed and allowed to access the resource and also wake up the process. As we see the whole semaphore operations in the way of code, let's make a quick revision. Here the value represents number of available resources. The list represents quick of waiting processes. The wait operation tries to acquire resource, blocks if unavailable. And also the signal represents releases resource, wakes up the waiting process if needed. And the block represents as it suspends the process, and wake up P represents as it resumes a blocked process. Now let us see the last topic, that is mutex logs. Mutex means the mutual exclusion. Logs provide a simple mechanism for providing critical sections by ensuring only one thread can hold the lock at a time. Like we cannot hold the multiple threads at a time, only one thread can be accessed. It is a log that allows one thread at a time to access a critical section. As we see, the important properties of the mutex is that the first one is ownership. Only the thread that is locked, it can be unlocked. And also if a thread tries to lock an already locked mutex, it blocks or waits. The main purpose of the mutex is to ensure one thread modifies a shared resource at a time. Now let's see the difference between the mutex and also as well as binary semaphore. First one, ownership. Mutex has ownership concept where semaphore doesn't. As we see, mutex has ownership, like only locker can unlock, while a binary semaphore cannot have the ownership, any thread can signal it. And also second one is uses. The mutex can protect the shared resource in the critical section, while the binary semaphore signaling between the threads. Next one, release. Only locker owner can release mutex. As we see, only owning thread can release in mutex. As we see in binary semaphore, any thread can release. Next one is priority inheritance. In mutex, supported in most of the systems, as the mutex is supported in most of the systems, while a binary semaphore usually not supported in most of the systems. Next one is recursion. As we see, many systems support recursive mutex, while the semaphores are not recursive. Let's see the examples of mutex and binary semaphore. Mutex means accessing shared memory in operating system, while binary semaphore is thread A signals thread B when the thread A only signals when thread B data is available. Let's see the advantages and disadvantages of the mutex. The advantage, what's the first advantage is that ownership. Only the thread that is locked can unlock it, and the thread cannot unlock it. It is safe, and also it is simple and intuitive. Like it can lock, do work, and again it can only unlock it. Next one, it supports priority inheritance, like it prevents priority inversion, and also some support of recursive locking. The disadvantages of the mutex is the works only for mutual exclusive, not general signaling. If a thread forgets to unlock, the deadlock has been happened. Only one thread allowed inside critical section, two should sometimes also. The more threads or more processes cannot be involved. Next, let us see the mutex implementation via code, and we see the mutex structure. First one, it defines a new data type called mutex log. It defines called mutex log. A flag, here the boolean available. A flag indicating whether the log is free, like true or taken, false. Next one is struct process into owner. It points the process that currently holds the log. Helps ensure only the rightful owner can release it. Next one. It function to request is acquire the log. Here the acquire. Here we see that it function to request the log. Log is the pointer to here the log. There is a pointer to the mutex. Let's see the while loop here. Here the while loop. Busy wait. The busy wait means here the busy wait means the process keeps checking until the log becomes available or not. Next one. Log available is equal to false. As it explains, once available, the process takes the log. If not, the process cannot take the log. As we see this, if the process once available, it records it records and it took the lock. Ensure only this process can release it. Only one process in what process running, that process can release it. Next one, release the lock. Here we see function to release the lock. Here we are defining the function to release the lock. Next one, here we are going if lock owner is equal to the current process, what happens? If the lock owner is equal to the current process, checks if the current process is a owner, prevents unauthorized release. If the lock unauthorized release and go into the if else condition, as we see, if it is true, it frees the lock. If it is null, clears the owner info. Lock is now ready for someone else. Like usage example. As we see, it declares a mutex logs variable. It infinite loop simulating repeated execution, and it process tries to entry into the critical section. Here it must be executed only one process at a time. Process exits into the critical section, freeing the lock, and the code can be executed without synchronization. As we see the quick revision of this code, the available means here true if lock is free, false if it is taken. Like next owner, process that currently holds the lock. Acquire means request the lock, waits if unavailable. Release means freeze the lock if current process is the owner. Busy wait means keeps checking until lock is available or not, like CPU consuming. Critical section means code that must run executively. After running of the code, it releases and it goes to the remainder section. Let us see the next topic, that is monitors. A monitor is a high-level synchronization construct that encapsulates shared data and producers that operate on it, ensuring mutual exclusion automatically. It is a synchronization mechanism that combines shared data procedures like functions and also locking that is handled automatically. And we can see the properties of these monitors are as it only one thread can be inside the monitor at a time. And the main advantage of this monitor is that it provides automatic mutual exclusion. And also the main purpose of this monitors is that it makes synchronization easier by hiding lock and unlock operations. Let us see the next one, that is monitor properties. The monitor properties is that atomic mutual exclusion, condition variables for synchronization, structured programming approach, and also compiler enforced safety. Now let us discuss about the condition variables. The condition variable is that it lets a thread wait until a condition becomes true. If the condition becomes true, then the process is to be executed. Here three operations are there. First one is wait, second one is signal, and third one is broadcast. Wait means thread sleeps until signaled. Signal means wait one waiting thread. Broadcast means we wake up all the waiting threads. A signal, difference between the signal and broadcast is that signal only wakes one waiting thread, means one process, while the broadcast wakes up all the waiting threads, means all the processes. Here wait means it sleeps until it gets signal operation. As it usually used inside monitor or with mutex. Example of this one is waiting a buffer to become non-empty. And also let us see the whole structure of the monitor via code. As we see, the first one defines as it declares a monitor named bounded buffer to manage a buffer safely. The next one is that int buffer of n, as it explains the actual buffer array of size to store items. The next one explains tags how many items are currently in the buffer. And in this one, in and out, what is in and what is out. The in is that index where the next item will be inserted. The out is that index from where the next item will be removed. Both use as a circular indexing via modulo. Next one, condition full and empty. What is full and what is empty? These two are condition variables. In that full represents used when buffer is full, like put is has to be wait. And also empty represents used when buffer is empty. Like consumer must have to be wait. Next one. The processor is to insert the items. Here the function defines to insert an item into the buffer. Like if count is equal to none. Checks if the buffer is full or not. If the buffer is full, put user waits until space is available. And also here inserts the items in the current index, like current index in. If moves to the next index using circular buffer logic, that is in plus 1% of n. If it is true, it increments the count. And also see here this represents as a signals a waiting consumer that item is available. It signals as a waiting consumer that the item is available or not. Next one. Here the function defines to remove an item from the buffer. As it checks the condition of the count is equal to 0, checks if the buffer is empty or not. If the buffer is empty, consumer waits until the item is available or not. It retrieves the item from current out index. This represent it retrieves the item from the current out index. This moves the next index using the circular logic. And also it decrements the item count. As this represents, as signals are represents a waiting position that the space is available. It returns the removed item. Returns the removed item. As we see the whole summary of the monitor structure, a buffer of n represents shared array of storing items. The count represents tracks as it tracks the number of items in the buffer. The in and out represent the circular indexes to insert and to remove the item. The wait condition as it suspends process until the condition is met, and the signal condition makes up a waiting process. Full as here full represents condition variable for full buffer and empty represents condition variable for empty buffer. Next, we are going to see the advantages and disadvantages of the monitors. First one, advantage. It as it is easy to use. As easy to use, like locking or unlocking done automatically, and is safest and is a safe structure like data plus log plus methods group put together, and also works well with the object oriented languages as Java uses monitors for synchronized blocks. Disadvantages: only one thread can enter even when no real conflicts are, as it may reduce the performance if there is no real conflicts also, like real problems also. Monitor logic depends on language or runtime. It can't implement in low-level systems like C without compiler support. Now see the condition variables advantages and disadvantages. Condition variables advantages. As we see, it's efficient in waiting, like thread sleeps instead of busy waiting, and it allows threads to wait for a specific condition. Example like buffer is not empty. That is a specific condition. Now, let us see the disadvantages of the condition variables. Must always be used with a mutex, like it has an extra complexity. And also, programmer must ensure that correct signaling, like forgetting signal causes, like if we forgot signal operation, it can cause deadlock. Now, let us see the some of the classic synchronization problems. In that one, the first one is producer consumer problem. As we see, as producer process generate data and place items in a shared buffer. Consumer process and it can remove items from the buffer. The most important point is that the buffer has finite capacity, as it represents two processes in a shared bounded buffer. The producer represents the it generate items and puts into buffer. As consumer removes the items from the buffer. The main goal is to producer does not add when the buffer is full and the consumer does not remove when the buffer is empty. And also here the producer consumer problem we see by using semaphore solution, as we can do this problem in the two ways, but we are discussing here semaphores, right? So we are going to see the problem in a semaphore solution. As we see in this code, we having full empty mutex. Full means count of filled slots. Empty means count of empty slots. And mutex means binary semaphore to protect the buffer. To protect the buffer. Now let us see the solution of the producer consumer problem by using the semaphore. First, we see the in buffer size as it shared buffer to old items. And here the in and out represents index where producer inserts, out represents index where consumer removes. Both are you both use as a circular indexing. Now let us see the semaphores using uses of semaphores. Here the semaphore mutex is equal to 1 represents as it ensures mutual exclusion only one process access buffer at a time. Next one, semaphore empty is equal to buffer size as it tracks empty slots in the buffer starts with the full capacity. And next let us see semaphore fuel as this is equal to 0 as this tracks the filled slots like it counts of the full slots start with the empty. Now let us see the producer process. Here defines the produce item. Now it represents as it waits until there is an empty slot or not. And also this wait is mutex represents is enters critical section to safely and to modify buffer. Here this represents as it inserts the item in index at a time. And also as is a presence, it moves to next slot by using this circular logic. As it represents, it leaves the critical section, and it signals it gives signals that a new item is available. Now let us see the consumer process. Waits as it represents waits until there is an item to consume or not. Here the wait vertex as it represents to enter into the critical section. Here, this represents that it retrieves the item from the out index. As this logic, out plus 1 modulo of buffer size represents as it moves to the next slot after retrieve the item from the out index. Signal of mutex means it leaves as it represents to leave the critical section. It represents and it shows that the slot is now free. Now let us see the quick revision of our code. The buffer means the shared space for items. The in and out represent circular indices for the insert or to remove the items. The mutex means ensures one process access buffer at a time. Empty represents semaphore tracking empty slots. As it full represents semaphore tracking filled slots. As it wait represents decreases semaphore blocks if the result is less than 0. Signal represents increases semaphore wakes up the waiting processes if needed. Now let us see the advantages and disadvantages of the producer consumer problem with semaphores. As the advantages is that ensures no overflow, like producer won't overfill buffer, and also it ensures no underflow also, like consumer doesn't read empty buffers. It prevents race conditions using mutex. Now let us see the disadvantages of the producer consumer problem. As it's more having the more complex logic like 3 semaphores, full and empty with a mutex, and also it is incorrect ordering of weight or signal can if the incorrect ordering of weight or signal can cause deadlock also, and also if buffer operations are written wrong or habit to be wrong, it hard to debug. Now let us go. We are going to see the next classic synchronization problem, that is readers problem. The As we see it, multiple processes want to access a shared database. Readers only read, writers modify data, allow concurrent reads, exclusive writes. Means that here the main goal is that the multiple readers can read at the same time, but writers need exclusive access. Like many readers can access only one only one writer with many writers cannot be possible. Like we see the examples of this reader writers problem is that multiple users reading the same database record and also only one user writing or editing at a time. Let's see the first reader writer solution. As it shared data, first one, as we see, as it in red read count represents like it tracks how many readers are currently reading, and also it helps to decide when to block or allow readers. Next one, semaphores. As we here use semaphores in the reader writer problems, as a semaphore mutex is equal to 1, as it protects access to read count, and also it ensures atomic operations are updates to the reader counter. Next one, as this represents, as it controls exclusive access for the writers, also use it to block readers when the writer is inactive. Next one, reader process. Now first see the reader process. As as we see in writing a do while condition, as it represents, as it locks access to the read count. If it locks access to the read count, it increments the number of active readers. If the read count is equal to 1, as this represents, it is a first reader block layer writers by waiting on write, as this represents unblocks access to the read count. Next, see the reading is performed like reader access the shared data, as this represents locks access again to update the read count, as it again it decrements the number of active readers if the read count is equal to 0, as this represents that is the last reader allows writers by signaling to write, as this represents unable to access the read count. Next, writer process. Like here, as this April, writer waits for exclusive access, blocks both readers and other writers. As the writing is performed here, as the writer modifies the shared data, as the signals like releases, as the signals like to writer, it releases exclusive access. Here, the main here what the problem is that is starvation. The main starvation problem is that in the first solution, writers may starve if readers keep arriving. The second solution gives priority to readers, but the readers may have to starve. The quick use of our first writer solution is that here the read count represents, as it tracks the number of active readers. The mutex products read count updates the write and ensures exclusive access for writers. The wait acquires semaphore blocks if unavailable. As a signal releases semaphore, wakes up waiting processes, as the first reader blocks writers, last reader unblocks writers. Let us see the advantages and disadvantages of the reader writes problem. The advantage of the reader writes problem, as it improves performance, like multiple readers can access simultaneously. Writers can get exclusive access only when they need it. Now let us see the disadvantages of the reader writers problems, as the balancing fairness can be tricky. Like here, the readers may starve writers, like writer waits forever when the readers accessing the process. Like writers may starve readers if the writer gets priority. That is the main problem. Now let us see the another classic synchronization problem, that is dining philosophers problem. Here the dining philosopher's problem is the five philosophers sit around a circular table. Each philosopher alternates between thinking and eating. To eat, a philosopher needs both edges and forks, that is chopsticks. Like it explains five philosophers at a round table alternate between thinking and eating, as they need two chopsticks to like as the chopsticks two stop chopsticks represents the shared resources. Why here, like an incorrect solution causes deadlock. Why deadlock occurs? If everyone picks up the left chopstick, like left shared resource at the same time, no one can pick up the right one. Like everyone waits forever. That is called deadlock here. And the correct solutions are, the first approach is asymmetric approach, and the second approach is limit concurrent tidying. As the asymmetric approach represents the odd and even philosophers. Odd philosophers pick right fork first, and the even philosophers pick left fork first, and then right. As it breaks circular weight, avoids deadlock. Second one. The second one is limit concurrent dining, as it use a semaphore limiting max up to 4. As it max up to 4 only it uses. Next one. Let us see the advantages and disadvantages of the dining philosopher's problem. As you see, the main disadvantage is that all philosophers pick left say resource first. The circular have to wait for the line. Circular wait has been happened. Everybody have to wait for the right shade resource. So here the deadlock has been happened. As we see in the correct solutions, first one is that asymmetric approach. The main advantage is that it breaks symmetry, like prevents deadlock easily. But here also one disadvantage is that still possible that one philosopher gets fewer turns, like starvation. Next one, limit concurrent ID. As for this one, the main advantage is that it guarantees no deadlock, improves fairness compared to asymmetric approach. The main disadvantage of this one is that slight reduction in parallelism, like only 4 can try at once, not more than that one. Next, we are going to see the solution, like incorrect solution and correct solutions of these two. Let us see the incorrect solution, like a semaphores for frogs, like as it declares the array of 5 semaphores, each representing each value representing a fork. Each fork is initially available. Semaphores ensure mutual exclusion here. Like only one philosopher can hold a fork at a time. Only one philosopher can hold a fork at a time. Next one, philosopher. Let us see the philosopher process. As this represents, philosopher picks up the left fork. Like for example, philosopher 0 picks up fork of 0. Like these represents that after picking of the left fork, then picks up the right fork. Like here, by this logic only, the next step will be continued. Like here, heat represents as it enters into the critical section, means ED. Next one. These represents it puts down the right fork, and after completing of this one, it puts down the left fork. Think means this non-critical section thinking. Deadlock here, deadlock. All philosophers pick up left fork simultaneously. The right fork is unavailable to them, and it uh, avails the deadlock. Next one, correct solutions. No, let us see the incorrect solution summary of that one also. Like fork of I represents, semaphore represents fork of I. Philosopher tries to pick up fork I. Signal represent, philosopher puts down the fork, and also here I plus 1 percentage of a modulo of 5, as it represents the circular indexing from right fork. The deadlock causes that all philosophers picking the left shade resource, like left fork, as the right circular for the right fork, the circular has to be weight, as it causes the deadlock. That is the correct solutions. The first one is the asymmetric approach. As here, asymmetric approach represents that even philosophers or philosophers. If here the value is divisible by 2, that is equal the divisible by 2, then even number philosophers like 0, 2, 4 picks the left fork, and then after picking up the left fork, they can pick the right fork. Else, if it is not divisible by 2, so these numbers are odd, like 1, 3, 5. 1, 3, 5. These numbers are odd, right? Odd number philosophers will occur. So they picks first right, and then they picks up the first. And then at last they picks the left fork. Next one. Limit concurrent dining. As we see here, as it allows only 4 philosophers to try to eating or to try to share the resources simultaneously at a time. As we see, Here the semaphore, as we defined as is a dining room, is equal to 4. A new semaphore dining is introduced here. Initialize it to 4. 4 means here the 4 philosophers can enter the dining room at a time. This breaks the circular wait condition to causes the deadlock. Next one. Let us see here, and as E represents the they are entering into the dining room. Philosopher requests permission to enter into the dining room. If 4 are already inside, the fifth must have to be wait. Picks the left fork. After picking the left fork, they picks the right fork. As it represents, they are entering into the critical section by like eating. As it puts down the right fork first, and then it puts down the left fork. As this one represents, as they leaves the dining room, allowing another philosopher to enter. Like fifth one is waiting, right? Thus, that must to be entered. At last, now the non-critical section is thinking. At last we can see the summary of these two, like asymmetric approach and the limit congruent dining solutions. As the dining room is equal to 4, as it represents semaphore limiting entry to 4 philosophers only. Wait of dining room, where philosopher enters dining room, picks the left, picks the right, puts the right first, and after that puts the left, and here leaves the dining room free and freeing and making a slot free, like to another like another fifth process as easy to enter. As we see the session summary, the key, like we studied about semaphores, like it provides a flexible synchronization mechanism with wait and signal operations, and also we see mutex logs, and also we see monitors. In that monitors, we see condition variables, we see classic problems, like classic synchronization problems that are potential consumer problem, and also dining philosophers problem, and also reader write problems.